Hello, and thank you for joining us today on this outstanding webinar, Commissioning Test Best Practices to Ensure 21st Century Cable System Reliability and Longevity. My name is Mike Beeler, and I welcome you today. I'm the National Spokesperson for the Power Delivery Intelligence Initiative, and I'm leading this webinar today from Distributech down in Dallas, Texas, where thousands of industry professionals are meeting to talk about the new future ahead of us, which does include underground. And so that's why we want to talk to you today about underground and some of the fascinating things that are going on in the world of underground transmission and distribution. Joining me today are Sharif Kamal from Southwire, Landry Mulimbi from Prysmian, and Ben Lands from IMCOR. Each of you gentlemen, Sharif, go ahead and say hello to the audience this morning.
Good morning. Thank you very much, Mike. Good morning, everyone. Thank you very much for joining us. I am very, very happy and honored to be part of this distinguished panel, and we talk about something that is near and dear to my heart. I have been with Southwire for about 7 years now, going on 8, and we are a founding member of PDI Squared, so I'm very, very honored to be here. Thank you very much, Mike, and I look forward for a great discussion and a webinar.
Great. Thank you, Sharif. Landry Mulimbi from Prysmian, say hello to our audience this morning.
Hi, Mike. Hello, everybody. Good morning. Thank you very much for having us and for attending this webinar. I'm very happy to be here. I think we'll have a very good discussion around undergrounding and commissioning tests. And I look forward to the discussion. I've been with Prysmian for now 5 years and also a founding member of PDI Square.
And Ben Lands, tell us how you're excited about being here today and give us a brief greeting.
Yes, thank you, Mike. Really glad to be here. Exciting topic for exciting times. A lot of activity in the industry around undergrounding, people wanting to make sure that this investment is going to be installed correctly and it's going to live a long life. And as chairman of PDI Squared, the Power Delivery Intelligence Initiative, I want to welcome all of you to this webinar. We get a lot of questions. We have a think tank focused on this area of effective T&D strategies for systems. How can we make these systems last longer, be more resilient? And in that capacity today, I'll be participating, and we're looking forward to a great discussion.
Thank you, Ben. Appreciate that. So just what is PDI Squared, the Power Delivery Intelligence Initiative? I'm going to share that with you in a minute, but I wanted you to hear the voices of the men that are joining us today because we're going to do this format a little bit different. We're not going to have a 40-minute presentation with 20 minutes of Q&A. Instead, we're going to go slide by slide. Each of us will ask questions and make comments, but we want you as the audience to ask questions on a particular slide as we go. We're going to talk about testing and commissioning T&D cables, and we're going to look at it from a manufacturer's perspective. We're going to look at it also from an O&M company's perspective. IMCOR is out in the field. They're commissioning cables, and then they're looking at the life of the cable life after the asset's been deployed. So it's going to be a little bit of a different format. Want you to be engaged with us as we go. So the Power Delivery Intelligence Initiative is a group of contractors and consultants and cable manufacturers and splice and termination manufacturers and other vendors in the underground utility space of our industry that advocate for underground and really want planners and engineers to evaluate underground versus overhead on a more level playing field. We seek to be a resource for planners and engineers and their executives and their regulators, for that matter, about what are the total cost of ownership of an underground asset versus an overhead asset. So we look at the life cycle cost from the capital cost through the operations and maintenance over the life of the asset. And we attempt to educate stakeholders, and stakeholders is a pretty broad word. Again, it goes from the engineers to the customer to even the shareholder, obviously the regulator. And we want to make sure that the information, the rich information that we have in the industry today about underground is out there and available. And we all do this really in the name of resiliency. Everybody in the industry these days is talking about resiliency. I'm here at Distributech. It's a huge topic, obviously. And underground is part of the answer to how do I make my system more resilient. Again, part of the answer, and not everything's going to go underground, and we acknowledge that. But in the future, we may see more and more going that direction. So we want to be a resource. That's what PDI squared is. So that's an introduction to what we're going to do today, and I think we'll go on to the first slide, and Ben Lands is going to kick us off on this first slide and talk a little bit about this slide. Again, audience, send your questions in as we go, and we'd be happy to address them in the context of this particular slide. So Ben, if you're ready, tell us a little bit about underground cable versus overhead systems.
Sure, Mike. So it's a broad topic, and we don't intend to cover every aspect, but we've put up a couple bullet points here to compare overhead and underground. And I think from what we're hearing from the industry, we hear over and over again that the overhead is less costly than underground. And we really want to make sure that we're looking at applications from more of a life cycle point of view. So some of these bullet points are really designed to communicate some of those key points that we need to be thinking about. So overhead, obviously the initial cost is frequently lower. It's easier to inspect and repair. You can push higher power capacity for longer distances. And while you need a wider right of way, in many spaces that's a possibility. I've been traveling across the country here over the last week and looking at a lot of different applications of transmission and distribution, and as we all know, there's lots of spaces in some places, so that's not necessarily a concern in some areas. However, we recognize that when we get close to population, the overhead is less appealing. It can be unsightly, and certainly there are many examples of that. Underground, on the other hand.
Well, let me ask you a question,
yeah,
Ben,
sure,
real quick, and Landry and Sharif, you guys can jump in here too. So number one, I'll just start off by saying you're not that dad that drives down the road and points out overhead power lines to his kids, are you? You said you're on a road trip. I'm betting you say, hey kids, look at that big 345 kV line. You probably get pretty excited about that. Let's talk about that. And I'll even say we got a question from the audience already, and I appreciate that. The question from the audience is, and it kind of goes in the direction of where I was going to go with this, because I do believe that many utilities across America, North America, and even the world are more overhead centric. And I know, Ben, you've thought about that. You've written a little bit about that as well. But here's the question from the audience. For the initial cost, how many times a factor higher are the initial underground costs compared to overhead? Now, I got an answer to that. Ben, I know you've got an answer to that. Let's play with that for a while.
Yeah, Mike. The number is obviously can be all over the map, and when we're just looking at initial costs, it can be twice, it can be even equal, but it could also be 5 times higher. I've heard some people say even 10 times higher. I think if we just include initial costs, it's going to be difficult in many cases to have that conversation. But if we look at the life cycle costs, what's it going to take to operate and maintain this line through its lifetime? What happens when we have resiliency events? How frequently do we have those? And that lean enterprise approach, if we have the opportunity to spend capital now that can displace future O&M, a lot of at least investor-owned utilities have a significant hurdle for the comparison of overhead and underground. And when you look at EEI data, you see that underground can be, on average, 10 times more reliable from a failure or outage standpoint. So that can be a huge opportunity to communicate a value that perhaps is not evaluated frequently.
Yeah. Okay. We'll come back to that because 10 times more. Where do you get that number? And let's talk about where we get that number. I will say a bunch of questions are coming in along the lines of cost, and appreciate audience that you're sending these in. And Landry and Sharif, I'm going to want you to comment too about transmission too. I got a call from an executive one time. He goes, Mike, he says, we're really looking at maybe doing some 345 kV underground. You're not telling me the 345 kV underground is going to be less expensive over the life of the asset. I said, I don't know if I'm prepared to tell you that yet, but 138 kV class and below, I will have that discussion and even debate with you. And this is along the lines of questions that are coming in, like what is meant by longer service life of an underground cable system? What is the current longer service life of underground compared to overhead? Distribution is more relevant than transmission. In your overhead, you can include the cost of vegetation management. So we got some great questions along these lines. I'm gonna come to you, Landry, and then Sharif, to ask you, what do you think about these things relative to transmission and distribution? Landry, have you got a couple of thoughts?
Yeah, I think great questions, and Ben touched on that. However, it is very important that we really look at the life cycle cost of those assets. There are, again, benefits in using a overhead conductor, but I think that these days we've seen an increase in the frequency and the severity of climate-related events, and undergrounding cables is a way to harden the grid, to lessen the frequency and the duration of those outages and the cost associated with those outages. So when possible, I would say that undergrounding is likely to be as costly as overhead in all things considered.
Yeah, Sharif, I'm going to come to you in a second. Questions and some comments keep coming in. Here's a comment from the audience. Overhead's clearly more exposed to the upsets like vehicles hitting poles, wind-blown upsets, broken cables coming down, lightning, ice, storms, and so on. So what's the availability indice for overhead versus underground for similar application under similar constraints? Okay, that's a great question, and I appreciate that, Manny, because we really don't have an indice. I just did a panel yesterday here at Distributech on that very topic. I had 4 utility guys that were doing strategic undergrounding programs, one from Dominion, one from We Energies. They're well into undergrounding, and then PHI and Tampa Electric, not so much. They're really starting their undergrounding programs. And we said, what is the index? We have indexes for reliability, SAIDI, SAIFI, MAFI, those things, but we really don't have an index for resiliency, which is what underground is providing when Manny, when you talk about things like big ice storms that have multiple day outages and such. Another question down here, it says, note that in areas where hurricanes and tornadoes or ice storms, the calculus can change. Indeed, the calculus, Dennis, can change. And I think that's one of the things that we're trying to identify at PDI squared is how does that calculus change and such. So, Ben, I know you've been playing with that a little bit as well, and some of the FERC 1 reporting information that we have out there, and PDI squared is looking at doing some things here even this year. Maybe I'll let you comment on that briefly, Ben, and then Sharif will come back to you.
Sure. So even in just an initial survey of FERC 1 reporting by investor-owned utilities, we see geographically 5 different utilities that we surveyed on their reporting, and you can see that just on what they've reported and comparing their very own data, so overhead versus underground, it's about a 3 to 7 times more costly to operate overhead on a year-over-year basis. And these costs do not include the scenario where you have a utility where a number of transmission lines come down or distribution lines come down in a storm, and then 3 to 5 years later it happens again, because these are considered low probability, high impact events and are actually reported differently. So to Mike's point, I really like what Dominion's doing and what they actually pitched to their regulators and saying, we're going to look at the total line restoration, TLR, as a measurement of how quickly can we get the grid back up and running, because we all recognize with electrification, the demand for reliable power is becoming more and more important. Some people would say that we can't evacuate with electric cars unless we have power. We can't go get food. We can't store food. We can't do most of our jobs without power. So it's becoming more and more critical. And so when we think about this, and we were on a webinar with Florida Power and Light, and they said that their state GDP is coming into effect here. They say for one day, $1 billion a day. So what if 10% of their system's out? Those numbers add up quick. And so if we think about the society impact of this electrification, I think it's an opportunity to think differently in some areas. And then looking at some of the other data, like I mentioned, the EEI data showing that underground, generally speaking, is 10 times more reliable than overhead. That's 10 times less truck rolls, 10 times less O&M, 10 times less potential safety instances, because we know that truck rolls are the most dangerous thing that utilities do. So really an opportunity to think bigger than just what does it cost up front.
Yeah, thanks, Ben. I appreciate that. Okay, we are coming your way, Sharif, and here's a couple of questions from the audience, but it's along the same vein. And the first question is really what's meant by longer service life of an underground cable system? And I know you guys at Southwire are working on that. You're doing mostly high voltage stuff, but the other question from the audience from a utility is when you talk, what is the current longer service life of underground compared to overhead, and is distribution more relevant than transmission? So talk about that longer service life and what we're seeing, Sharif, today with new technologies, 21st century technologies really on the cable systems that we're installing.
Yeah, thank you very much, Mike. Actually, okay, so I have to tell you something. Answer one question. I am one of the people who always look at overhead lines, and this is not because of the overhead line itself, but because of the insulator. My first passion was insulation, and I studied and worked on overhead line insulators, and so every time I look at them with passion. So I am guilty as charged in this on this side. Overhead lines also was always taken as sign of progress or modernization. Countries that have overhead lines or advertise having overhead lines were always, considered to be modernized countries or electrified countries. This is really it's ironic, not ironic, but it's interesting because Southwire as a company was created to enable that part of electrification of rural America. So that's one thing. In terms of service life, we are not talking about design service life per se. We are talking about actual service life, and that's because of everything that we talked about before, which is the exposure to the elements, exposure to animals, exposure to birds. There are cases where birds would actually cause overhead lines to get out of service, not even touching them, just flying over them or flying off the cross arms on top of the insulators and their excrement causing the flash over. So it is the availability to service. Goes back to the point that you brought up before, which was the resilience. How much is this line or is this service available to me, and with minimum disturbance? We all remember Superstorm Sandy. Superstorm Sandy caused so much trouble and so much outages everywhere. And I remember that at that time we had an underground system that was a 345 kV system that went actually out of service, and everybody was very intrigued. Why would that happen? And it turns out that it was actually a flashover on the insulator next to the termination in the substation. that took the system out, but it was back right on in service on the spot. All the other overhead systems were damaged beyond, or not all, I can't say all, but many of the other overhead systems were damaged beyond repair, instantaneous repair. So their availability to transmit power were really diminished compared to the underground system. I saw a question in the audience we're asking about cost model. There is actually a very nice write-up and a paper in the Seagray Electra 256. If somebody wants to look at it, it actually provides a cost model, and it comes back really the difference between the overhead and underground. If you take everything into consideration, it comes to the value of the land. When you put an overhead line, you cannot use the land underneath. It becomes protected land. When you put an underground cable, it can be used. The land on top of it can be used. And if you are in the Fifth Avenue in New York, the value of the land, the commercial value of the land, or the use value of the land is way higher. So it becomes if you monetize everything, the underground system becomes even much cheaper than overhead lines. Where, of course, if you are in the middle of nowhere, like where Ben is now, land is cheap and there's no use for the land, the commercial use for the land. So it becomes more expensive to put an underground.
We're gonna go back to Ben and let him finish this particular slide. Or any last comments that we didn't cover in the Q&A? Audience, that was an outstanding group of questions, and we appreciate that. And then we'll Ben and wrap up on this particular slide if you've got any concluding remarks that we haven't covered already.
Yeah, I'd just like to point out that in the past there's been some questions about the design life of underground, and the reality is the materials are far advanced now. The manufacturing process is advanced, and we're recognizing that if we can not only get this high quality product that doesn't have some of the issues that early versions of underground cable had in the ground, and if we can install it correctly, we can not only achieve reliability on the order of 10 times more reliable than overhead from a service life standpoint, we can achieve much higher than that. And if we compare, say, the service life of wood poles, there's science and papers out there. Thinking of a Giacabo paper that some of my colleagues wrote with me, and was a review of the science, some of the data that's out there, suggesting that cable systems could last well beyond 100 years. So our paradigm of the old 30 to 40 years, even We Energies, who just presented this past week at Distributech, they're promising a 60-year life for their assets. So it's a different world, and that's what we're here today to talk about. Some of those nuances that perhaps we're not all thinking about, and see if we can't get on the same page with that new and
good points, Ben. And Sharif, we're getting ready to shift to you, but I'll just say that Ben, the point you made was echoed by Sean in the audience. I agree on higher resilience and lower costs for underground, especially in areas susceptible to weather events, those high impact but low probability events. But that's only true, Ben, to your point, if you have good O&M programs to baseline test, pre and post install, and then do the routine test for condition monitoring. If you bury your cables and then forget them, you'll have problems, according to this attendee, which I think we'd all agree with. And I know, Ben, that we've talked about even putting commissioning of cables into specifications for cables as engineers build new systems. So great point. Appreciate you making that point for us, Sean, and we're going to move on to the next slide, Ben, and we're going to hand off to Sharif. Sharif, talk to us a little bit about cable system life, cycle, and quality control, and what your perspective at Southwire is, and even greater than Southwire, the industry, really, because we at PDI Squared, actually, we advocate for the industry. And talk to us a little bit about that, and give us 2 or 3 minutes of thoughts on this, and then audience, send us in some questions.
Absolutely. And actually, it is interesting that Ben made a good segue talking about the materials. Before we even make a system, we look at what the materials are and how they are now and how they progressed, and the manufacturing processes. Before we actually design an underground system, we look at the surface conditions. What surface conditions are going to be? What the material properties that we're going to use? What's the grounding scheme? We took everything into consideration, maintenance consideration, and quality. How do we ensure quality? The process of manufacturing an underground cable is a complicated or a complex process, and it involves during the manufacturing process. It involves quality at every step of the road. We don't wait until the end of the line where the cable is already produced to ensure its quality. There's quality for the stranding processes, and then there's quality for the extrusion process, and measurement of the properties of the material and the performance of the material. Manufacturing uses X-ray machines to look inside the cable, make sure that the dimensions are within the tolerances, and we continue all the way until the final manufacturing process, at which process is completed, at which we do a complete test on the cable. Every single foot of the cable is tested in the factory, is tested under high voltage testing, is tested for PD, is the jacket integrity test. It's tested, particularly if it is, the jacket is tested whether it's high voltage or medium voltage. High voltage is tested with what we call jacket integrity test because it has a conductive layer on the outside. Medium voltage is tested using the spark tester. We make sure that the jacket is integral. The jacket, as everybody knows, plays a major role into the protection of the cable and insurance its long life in service.
And I'll say, Sharif, go ahead and comment briefly on the quality of the materials that go into the cable itself. I know that there's a couple of PDI squared members, like Dow in particular. All they do is they make the product that goes into the cables, and so you probably have very tight specifications on the kinds of materials that even go into making up these specialty cables.
And that's absolutely right, absolutely. And this is a whole science by itself. Is to how to ensure that the material is not only the proper material, the proper properties, or the adequate properties, but also the cleanliness, the number of contaminants. It's actually countable, the number of contaminants per unit volume. And as the voltage class goes up, either those regulations are becoming tighter and tighter and tighter. And also there are materials that are aimed for conditions, for example, like tree retardant material or tree retardant cross-linked polyethylene, which is geared for medium voltage because of its susceptibility to be in water, to reduce the water trees formation into the cable. Higher voltage is super smooth shields, insulation and conductor shields. As the voltage goes higher.
And Landry, we have a question. We have a question from the audience, Landry, that I'm going to give you a heads up on here about terminations and splices. And the question is, and I think you can comment on this with regard to quality control on some of the components that go into a cable system. The question is, how do you claim a cable life of 60 to 100 years, and then how does that apply to joints and terminations? Do you want to comment, Landry, on some of the QA/QC that goes into joints and terminations as part of cable systems?
Sure. I'm more of a testing expert, but I have a few comments to make, and then Sharif can add on to that. But I would say that today, most of these accessories, for example, joints and splices, are actually manufactured in the same way as cables are manufactured. So extruded in the same way, very similar, tested, qualified, let's say, materials. And so we, of the industry, is trying very, very hard to design systems that are meant to last a very long time. And when accessing
Yeah, and
them,
the beauty, Landry, of that is that we're seeing a lot of these splices and terminations now made in the factory as opposed to being made up in the field, and that's helping us a lot with our quality control. Ben, I'm going to come to you because here's a question right up your alley from the audience, and thank you, Jose, for this question. A new cable's been installed. How many years after this installation should we perform insulation diagnostic tests?
Well, the reality is, as Sharif said, every joint or termination or cable reel is tested in the factory using an overvoltage and a partial discharge test. And the reality is, as best practice, and we're going to be talking more about this later in this presentation, but I'll mention it now, if we can repeat that test in the field, we can also do a power frequency or near power frequency partial discharge test in the field and get a comparative baseline. Unless that asset is damaged in some way, and we'll talk about what are the flags for a system that's been changed somehow by an extreme event, there's really no reason to take another look at that, because these materials are so stable, and they're so stable within the environment. Unless they've been impacted by some major event, they're not going to change condition by themselves. This old thought that somehow the materials are just falling apart, just sitting there, that's really more of an overhead mentality. These materials, provided they're installed properly and handled and operated properly, there's no reason for them to just start falling apart. The science is stable.
Yeah. Sharif, we're halfway through, and I'm going to give you a chance to make a couple of a minute or so of concluding remarks on this slide. We've got some more questions from the audience, but if you had a couple of concluding remarks about this particular slide, go ahead and make them right now.
Yeah, I would say that not only the final product is tested for like electrically for over voltage and underground and partial discharge, but also every component is tested material-wise. Make sure that what we get out in the field is exactly what was designed, and that includes the joints and terminations, which are the prefabricated joints and terminations, which are the majority of what we use now on cross-link or solid electric cables, are 100% tested into the factory.
Yeah, and the beauty is these. Go ahead.
Yeah, go ahead. I was just saying that every component that is manufactured in a company in the factory is tested and sent intact to the field. That's where the next step in the system, in constructing the system, takes place.
Exactly, and we're going to shift it over now to Landry from Prysmian to talk a little bit about that quality assurance process as it continues to go from the factory into the field. So Landry, make a few comments here on this slide. We got a lot of questions coming in from the audience. I'll throw them in here as we go.
Yes, thank you, Mike. And I see we are almost half an hour through, so I'll be brief here. But Sharif mentioned a lot of things that can be done at the factory, all the quality checks that are performed, and that's the first step. There are now other pre-installation steps that can be taken for the cable system, and that should be considered in order to ensure a quality install in the field. So
I got a great question here, Landry, from the audience, and I think this is right along the lines of what you're talking about. It's like here's from the audience, a big industrial customer. I understand QA for underground cables, especially medium and high voltage applications. My question is more about installation. So, and I'm interested in what Prysmian's perspective is on this, and I think Prysmian might even be an EPC contractor, so you probably have a pretty good feel for this. Who's qualified to install these types of systems? What training's required? What certifications are available? I want to hire someone who I feel comfortable that they know how to splice and terminate underground high voltage cables, and what certifications are available for installing these underground high voltage cables. You can comment on that, Ben and Sharif, if you'd like, but Landry, what do you think about that?
A great point, and you are correct. Our company, but I think it is the same with many others. We provide, let's say, a turnkey solution, and so we have a dedicated project team that is continuously training splicers, people who live and basically splice cables their entire lives. And so we spend a lot of time from a, let's say, a training certification point of view to ensure that the people who are going to install those accessories are extremely well qualified. This is very true on the transmission side, but I would say the approach is very similar on the distribution side, where we will always recommend to train, certify the people that will install those accessories if it is not us. So spending time on your talents, the people in the field to ensure that they understand what they are doing, that they do it according to, let's say, the manufacturer processes is key. And if you do that, I'm very positive that those accessories will be properly and successfully installed. But Ben,
I would agree with you, Landry. I think the big cable manufacturers like Southwire and Prysmian are well qualified to put these things in these systems in on a turnkey basis. I know Ben's got some comments on that. Ben, here is a question from a utility that is right in the sweet spot of what you do at INCOR. What are the recommended testing practices to be performed on cables upon delivery for acceptance or prior to installation? So now, again, we're out of the factory. We're delivered to the project site. Contractors getting ready to put it in according to the specification. Any testing that needs to be done before that?
Yeah, so after training, we obviously want to make sure that they have proper documentation and handling. Landry, has probably some more comments here on this particular slide. But for medium voltage, there isn't much you can do other than checking for, say, shorts in the system, because it doesn't have that conductive jacket, whereas at high voltage or transmission levels, you have a conductive jacket. You can actually make a measurement on the jacket itself to see if there's any significant punctures, which would suggest that maybe the cable itself has been damaged. As far as the joints or terminations, splices or terminations, there's not much you can do until they're installed. They've been factory tested with a power frequency PD test. Then when it's in the field, you're really going to need to wait till it's installed. But training is key to make sure that people not understand just what are the steps, but why they're doing what they're doing, and understanding what a defect looks like. There's a lot of folks in the industry, even looking at a defect, wouldn't recognize it, and that's key part of training. Not just how to install, but what to look for and how to make those repairs on install.
Okay, Sharif.
Yeah,
go ahead.
I would say, remember that testing is not, the purpose of testing is to make sure that nothing went wrong, but it is not a cure for a problem, for a process that was not done properly. So one of the things that I found out is particularly for medium voltage, when they directly bury the cable in the ground, if the specifications for directly burying the cable, if the ground is full of rocks and sharp areas, if the compaction is not right, there are rules to do things right. If you follow these rules, then the test just verifies that you didn't have a problem. It doesn't help you much if the test shows that you had a problem and now you have to dig up the cable again. That's not the idea. The idea is do the right steps, including the cable handling, including the documentation, of course, including the training. Don't get people who don't know what they are doing and then discover that they did a bad job. Yeah, that's great. That's great to discover that they did a bad job and you fix it before you energize the system. But that's not the point. The point is make sure that the steps are followed properly, and then put the icing on the cake. by doing a commissioning test to ensure that nothing is left for chance. So that's something that I just want to make sure that people should not rely on the test to catch the problem because they were careless in the installation phase or in the handling phase.
Good point, Sharif. Landry, any concluding remarks on this pre-installation slide that you have before we move on?
No, I suggest we move on. Thank you, Mike.
Okay, great discussion, great questions, audience. So thank you very much for those questions. Appreciate that. And let's see, John, can you go ahead and advance to the next slide for us, please? Okay, well, there we go. I got that screen back. Sorry about that. Okay, so we're going to talk about quality assurance post-installation. So we talked about it pre-installation. We talked about what's going on in the factory. Ben Lands from INCOR, you're going to talk a little bit about quality assurance post-installation. And give us some comments on this slide, if you would, please.
Yeah, sure. So
and audience can continue to send your questions in. Excellent.
So upon installation, we need to make sure that our cable and accessory, our cable and arresters are properly installed and that there's inspections done during that process. So as Sharif said, all tests rely on the fact that they're going to tell you a condition of the asset, but if the asset is not going to be stable in that condition, for example, if somebody didn't rack a cable in a vault properly and it's going to fall down and yank on that cable and pull the cable out of the joint or misplace the joint, no test can predict what's going to happen in the future if the material is going to change. So we need stable materials by design, obviously, but also by installation. So key component is making sure the accessories are inspected to make sure that they're in a stable position. And then we test them. Now we know the asset condition. We can then predict how it's going to perform. And arresters are a key place here because they're going to protect us against the arch enemy of cable systems. By far, the vast majority of faults are associated with voltage transients. While overloading can be an issue, overheating connectors can be an issue, the vast majority of issues from a operation standpoint are associated with transients, voltage transients. So making sure our arresters are in place, the surge arresters, because it's not just lightning, it's the everyday surges that are going to stress the system, and we need to protect against extreme voltage. So making sure they're installed properly with proper lead lengths and in proper positioning, right sizing, and so forth. We need to make sure that those support structures and clamps are in their proper place. Again, if we've had cases where clients have had on a 345 structure of a termination, the cable, they get some movement in that structure and it actually starts sliding the stress control element off position. No test can predict that. We have to plan to have a stable system. Then the test can give us a confidence that the system's going to perform to expectations. Link boxes and bonding leads for cross-bonded and single-point bonded systems. This is typically a transmission application. You need to make sure that those connections are proper. Can't tell you how many times that even after a test is complete and everything looks to be properly installed from a dielectric standpoint, somebody connects up the bonding leads incorrectly. That's a human process. It can happen. The system's not going to survive for its design life. So making sure those we have component inspections. Then the actual test itself, we're advocating that we really look to the industry experience of testing 100% of reels and pre-built terminations and joints in the factory with an overvoltage at or near power frequency PD test. And there are standards for this in the factory, and if we can mimic these types of tests in the field, that's going to give us the confidence that the system is installed properly from a dielectric standpoint. Obviously, if you have conductive jackets, that jacket test is a really low-cost, simple way. Typically, that's only a high voltage or a transmission class opportunity. And if you have a transmission cable system, it's not very common with medium voltage, but if you have an optical fiber, you want to do a pre-test on that, an optical TDR, to make sure that that's properly installed. And to reiterate this point, I mentioned the most challenging operational issue is voltage transients for cable systems. But the biggest, if we look at the statistics of what causes cable systems to fail, it's primarily the human element. Maybe to a small degree, there are some manufacturing issues, but the vast majority, well over 95% here, are installation, human handling, and that little graph to the right-hand side shows that. This is the medium voltage data over 104,000 cable systems assessed in the field with a power frequency PD test. And you can see that 63% met industry expectations. For example, IEEE 404 for joints, which would be no partial discharge to 1.5 times operating voltage with 5 PC sensitivity, for example. And after mitigation, after fixing what could be repaired there on site, even 17% were left as substandard. So it's a significant problem. This doesn't mean that every component that's not meeting the industry expectations on installation are going to fail right away. In fact, we are looking at 30 to 40-year-old cables that are still going to failure with defects in them caused by installation. So these defects can take a long time to go to decades to go to failure. But if we're going to have cable systems last much longer, the 60 to 100 years, we're going to have to get these issues out of here. We can't start the life cycle with known issues that could be avoided through training, inspections, and testing.
Well said, Ben. Well said. And Sharif and Landry, I'm going to give you a chance to comment. And as I mentioned, a couple of the questions that have come in from the audience, and I think, Ben, you might have touched on them pretty well here. Are there any ANSI or IEEE standards for testing and commissioning? Yes, there are. You mentioned a couple of them. You talked about partial discharge. And this person asked a question about the IEEE 400.3 standard. Another question about the conductive jacket. I think you made reference to that. Here's the question, and I guess I'll roll this over to Landry or to Sharif if either one of you would like to comment. It says, practically while handling the cable on the rollers during installation, can the graphite get damaged, and what should the minimum thickness be of that graphite as it's installed? You guys have comments on that, or Ben, do you have a further comment about that?
That's a Sharif question.
So,
Sharif, what do you think about
well, I can speak to this a little bit. I would not definitely specify any numbers. This is a design criteria for the cable manufacturer himself, or cable manufacturer. But in general, there are two ways to have that conductive layer. It's either the graphite or a co-extruded polymeric conductive polymer on the jacket itself. The way these are tested, they use a relatively high voltage, so even small scratch or damage in one local area would not affect would not result in false negatives. So they can be scratched, but they would still continue to perform their function. But I would not be able to provide a specific number.
I think you just answered a question that just came into, and the question was whether minor damage on the outer sheath during installation can lead to failure of cable during service. So that was another good question from utility. So let's shift back to Ben on this, and then go ahead and wrap up this particular slide, Ben, and we'll move to the next, keeping our eye on the clock here. But this question is, as far as current systems in use, is there an age range that should be prioritized for testing, like 15 years, 30 years? How often should testing occur if the cable lasts indefinitely? That's a good question. So we say, well, these cables can last a long, long time. Well, how often should we be testing then? Ben, you want to take that and then wrap up your particular slide? We'll
actually, I think that we should move on to the next slide because that's what we're talking about in the next slide.
Okay. There you go. Ben Lance from IMCOR, what do you think about service life extension best practices?
Yeah, so really, if we commission the cable properly, we do our training, we do our inspections, we do an effective at or near power frequency partial discharge test in the field, we got a baseline of that asset. Unless there's an extreme event, there's no reason to go back to take a look at that. Reality, if you want to be conservative, we're looking at a decade or two of time frame. The data that's out there now is well over 20 years of experience. The reality is these assets don't move unless they're impacted. So what are we looking at? Well, routine inspections could be looking at shield brake systems for transmission systems. It could be looking at the civil or mechanical structures, the support structures. But really, we get to this monitoring aspect of this, and I know Landry has some thoughts on this on our next slide. But if you have an extreme voltage, say during fault, or if you have a withstand test, or a failed arrestor, or some type of line resonance happening, or a significant amount of reclosing, cap bank switching, and so forth, these kinds of events, if not well protected, if arrestors are not doing their job, our systems are seeing extreme voltage. And as a cable aged, the AC breakdown, the ability to withstand extreme voltage drops substantially. And if we're not protecting our system, not just how it's going to be as installed, but as it's performing during service and as it ages, we will start to see new issues show up. Obviously, we have an overloading event or a connector failure. That could be, hey, we perhaps have a systemic issue. Maybe someone didn't wire brush the aluminum in the connector or something like this. If we have an issue come up, then we can go back and take a look. Mechanical issues. We have a structure. We actually do some repair of a transformer or something. We have to relocate some terminations. When we touch it as humans, this is a good opportunity to go back and take a look at that baseline. And then using infrared inspection under high load conditions and low light to see, are those connections solid? And so we can do it just by using data. How did we actually touch the system, yes or no? And if we did, what did we do to the system? But as a setup for the next slide or next point, there's ways of monitoring these assets. But before I go and suggest that we move on to the next slide or ask for other comments, I want to point out, here's some data here. 4,000 miles of power frequency PD testing, 0.01 failures per 100 miles per year, whereas doing no commissioning test, we've seen ranges anywhere from 1 to 4, even to 6 failures per 100 miles per year. So you're looking at well over an order of magnitude of performance improvement if we've done an effective commissioning test.
Okay, well, thank you, Ben. I appreciate that. Keeping our eye on the clock, I'm going to give you the last utility question, Landry, as we go into event monitoring opportunities. I'll read this question, and I'm going to push the slide to you, but go ahead and start to comment on it. Thoughts on effectiveness of using partial discharge measurements for transmission cable monitoring. I'm aware of a few utilities, this is a utility question, who had online partial discharge systems installed and had a joint or termination failures that were not picked up by the online powered partial discharge monitoring. Any thoughts on that, Landry, as you give us your remarks on further remarks on this next slide?
Yeah. Thank you, Mike. So I think that's the point we are trying to make now in slide number 9. I think one thing we need to be very conscious of is that what we've talked to is, let's say, best practices and recommendation. However, we also have to be aware that not all projects, not all sites will implement all these things for many various reasons. And so being able to monitor afterwards, being able to inspect afterwards for things that may not have been tested or looked at during the overall process is a positive thing. So there are many things that can be monitored, but what we are seeing today becoming more and more useful to the industry to, let's say, improve resilience, reliability of the grid have been fiber sensing technologies. So monitoring temperature, looking for hotspots along cable system, acoustic sensing, looking, for example, for third-party intrusion. I remember this ICC presentation from a US utility who said that they had no cable system failure in their network related to, let's say, quality issues, but they had many failures related to excavation. So obviously we were in a very busy American cities and people building buildings, digging and pulling cables when they were not aware that cables were there. And then there is partial discharge monitoring as well as other, let's say, key parameters that can be monitored. I cannot comment on the examples that the audience shared, whether online PD worked or didn't work, but I think that, again, if there's been a near or power frequency test performed during commissioning, followed up by a PD, let's say a permanent monitoring solution, the likelihood of finding issues coming up during the life of the asset is quite high in my opinion. So we getting towards the end, so I'll let you.
Okay. Well, I'll tell you what, we're right up to the top of the hour. We're going to have to wrap this up, and I would say that in your closing remarks, each of you, I'll come to you, Sharif first, and then Landry, and then Ben. Give us some closing remarks. We have a summary slide, but I'm not able to advance it right now. But go ahead and make some concluding. Yeah. Go ahead and advance that to our summary slide and then to our final slide. Audience, we had a lot of questions, and if I didn't get to your question, I apologize, but we had well over 40 questions. That's exactly what we wanted to accomplish. We wanted to talk about the things that you wanted to talk about. So I say, Sharif, give us a couple of concluding remarks and tell the audience thank you, if you will.
Yeah, absolutely. I will start by saying thank you. It's a great discussion and it's a great engagement from the audience, so I thank you very, very much. I think the message that I would like to leave you all with is that while overhead has served the countries and the world very, very well, our the recent needs for reliability and resilience suggest that we should look at undergrounding as a potential solution. I am in no way saying that it is the solution for everything. But it is possible to design and implement and install and implement and operate a very reliable underground system where it does not break the bank over the life of the asset. So consider it, give it a good thought. Make sure that you do the right things. Do not skimp on the different steps because they cost money. Everything costs money. But if you do it right, you would have a very, very reliable asset for a long, long time. Thank you very much again. Thanks, Mike. Thanks, my esteemed panel. And I really appreciate the opportunity.
Thank you, Sharif Kamal from Southwire. We appreciate those comments. Landry Malimby from Prysmian, what did you add for closing comments?
Yeah, first of all, I want to thank all the participants and the panel for the opportunity and for listening. What I would say is that there are ways for us in the industry to really harden the grid infrastructure and in consequence reduce frequency and duration of outages. And one of these ways to do it is undergrounding. As Sharif said, if you do it, it is important that you do it right. And there are, let's say, places like PDI Square where you can get educated and get the information that you need in order to get the support required. And there are, as I said at the end, also many innovative solutions that have been developed over the years to enable sustainable grid modernization. So lots of things that can be done. And again, thank you very much to all of you today.
Thank you, Landry. And Ben Lance from IMCOR, bring us home with your concluding remarks.
Yeah, as chair of PDI Squared, I just want to thank the audience for their participation, the panelists. This is exactly the kind of discussion we're having at PDI2.org. If you want to know and hear more about best practices in undergrounding, check us out, PDI2.org.
Thank you very much, Ben. I appreciate that. My name is Mike Beeler. I'm the national spokesperson for the Power Delivery Intelligence Initiative, and we appreciate you listening in today. Join us later on this summer. We have a whole series on the cost of underground distribution 2.0, where we talk about the life cycle cost, total cost of ownership of underground versus overhead over the life of the asset. So thank you, T&D World. We appreciate you guys being involved in this today. And John, I hand it back to you, and everybody have a great day and be safe.
Well, for those questions that we didn't have time for today, T&D World will share those with today's presenters, and they will get back to you via email as soon as they can. That concludes today's presentation. On behalf of T&D World, I'd like to thank Mike, Ben, Landry, and Sharif for presenting today. I'd also like to thank PDI Squared for sponsoring today's event, and of course, all of you for joining. Today's session was recorded and it's going to be available on the T&D World website within the next week. You'll be notified by email when the archive is available, and the email will have a link for the presentation. You can use the link to go back and review the webinar. You can also share the link with coworkers and peers who you might think would benefit from viewing the webinar. It's free. It'll be available on the T&D World website for several months. That concludes today's presentation. On behalf of T&D World, I'd like to thank Ben, Landry, Sharif, and Mike for presenting today. Thanks for tuning in, and make it a great day.